Welcome back. Okay. Um, Let me just get organized here and set up. Okay. Now, um, strange. Okay. Hmm. Yeah. Try that. See Nothing. Okay. I'm just trying to get organized here. Bear with me for a moment. Alright. Okay. Yeah. Right. Electrical machines. Electrical machines. NVQ Level 3 electrical installations. Okay. Terence Payne tutorial. Okay. Now I hope this is bright enough for you to see. Okay. Now what I want to talk about today is the auto transformer. This is electrical machines session 6. I repeat, electrical machines session 6. Okay. The auto transformer starter. Now this method of starting is used when start delta starting is unsuitable, either because the starting torque will not be sufficiently high enough using that type of starter, or because only 3 terminals have been provided at the motor terminal box, a practice commonly found within the UK water industry. Okay. This again is a 2-stage method of starting 3-phase squirrel cage induction motors, in which a reduced voltage is applied to the stator windings to give a reduced current at start. The reduced voltage is obtained by means of a 3-phase autotransformer, the tap windings of which are designed to give 40% to 60% and 75% of the line voltage respectively. Although there are a number of tappings, only one tapping is used for the initial starting, as the reduced voltage will only result in reduced torque once this has been selected for the particular situation in which the motor is operating. It is left at that position and the motor is started in stages. This is much like the star delta starter in that once the motor has reached sufficient speed, the changeover switch moves onto the run connection, thus connecting the motor directly to the 3-phase supply. Figure 6.31 illustrates the connections for an autotransformer starter. And there you are. Okay. Let's bring up a little bit. Now here we're looking at the rotor resistance starter. Let me see if I make sure I've moved this down to that side sufficiently. Okay. Here we have the rotor resistance starter. This type of starter is used with a slip ring wound rotor motor. I like that. Let me just say that again. With a slip ring wound rotor motor. I'll do it again. Slip ring wound rotor motor. I like that. That has amused my senses. I'm sorry. It's okay. It's just a childish thought. Sorry. Let's get on. Okay. The slip ring wound rotor motor. These motors and starters are primarily used where the motor will start against full load, as an external resistance is connected to the rotor windings. Through slip rings and brushes, which serve to increase the starting torque, when the motor is first switched on, the external rotor resistance is at a maximum. As the motor speed increases, the resistance is reduced until at full speed. When the external resistance is completely eliminated, the machine runs as a squirrel cage induction motor. The starter is provided with no volts and overload protection, and an interlock to prevent the machine being switched on with no rotor resistance connected. For clarity, these are not shown in figure 6.32 since the purpose of the diagram is to show the principle of operation. Okay, the diagram is only showing you the principle of operation, so don't do a bit more additional work for yourself so you get a full picture overall. Okay. Okay. I'm just going to the rotor resistance starter. Make sure you can see it. Okay. Now, I would always recommend that you draw these diagrams out. Okay. It makes work a lot more easier to understand. Okay. Sorry, I'm just bear with me for a second while I try to get this. I'm hoping that the green shows up the text when I look back at this, because I'm never quite sure how this goes out sometimes. But I'm not, when I play it back, I'm normally quite pleased with it anyway, so I won't say too much on this occasion at this point. Speed control of DC machines, okay. This I'll leave you to read for yourselves. I don't need to read this out for you. Armature resistance control, we just looked at that, basically similar process, okay. In this case, we are reducing the voltage across the armature terminals, okay. And this is something I'll look up, see whether we have anything additional in regards to modern day references to it. Okay, here you can see the disadvantages, okay, etc, etc. That's something I'm going to leave to you to read, and hoping that should be a problem. Can I make that bigger? Should I make that bigger? Let me just see whether I can make it a bit bigger for you to look at and interpret a bit more. Let me just, yeah, right, let's make sure we've got him all in view. Okay. Yeah, I think I have, yeah. Go back a bit. Okay. Yes, I think I can get away with it. Pulse width modulation, okay. We know all about the problem with the variable resistor. Although it works well, it generates heat and hence wastes power. PWM DC motor control uses electronics to eliminate this problem. It controls the motor speed by driving the motor with short pulses. These vary in duration to change the speed of the motor. The longer the pulses, the faster the motor runs, and vice versa. Should I bring it up any larger, do you think? bring up in the largest, should I? Let me see what I think. I'll just see if I can, if it would benefit me. Okay. So I'm just trying to see if it will benefit me, if I can make sure that it can be read. Let me just try it. If it not, let's try and make it a little bit larger, so that it's okay. Okay. Yes. Okay. Yes. Okay. I think we can go cover that. Yeah. Yeah. Good. Okay. Let me just bring this page into view. Okay. Bring it across. Okay. Speed control of AC induction motors. Okay. And we'll see what we can do with those on a point of reference at the end. So bear with me, because I want to see if I can add something more into this. It's just an idea I have. It may not work out for everybody, but it's worth taking a shot at. And here we're looking at speed controls of AC induction motors. That's for you to look at. Variable frequency drive. Okay. And again we can. Am I too far over? No, I'm not far over enough. Yeah, I can. I got you. Okay, good. Good. Got you. Okay. And here. Right. Now, on the job, motor noise. You are asked to investigate a problem in the plant room of a hospital, as the estate's maintenance manager has reported a noisy motor on the air conditioning system. When you look at the motor, you find that as well as it being noisy, there is a vibration. Do you think this is a real problem? If so, what action would you recommend? So here you're looking at trying to determine, one, why is it vibrating? Two, why is it noisy? Now you remember way back when we started, we looked at greasing and the bearings, and we look at the bearings could have an issue. Okay, so if it's noisy, could it be the bearings, and are the bearings being worn? And when you look at bearings, you need to look at bearings from both ends, not just one end. Okay. Did I? Yep. I got you. Okay. Okay, let me just bring you into play. And let me bring you into play a little bit more this side. Oh, thank you. Okay. Now, activity, what I want you to do is to have a look at this activity. You are working in the environment already, so you're there somewhere. If not, whether you're at college or uni or in a factory work, this would apply to yourself. Have a look at some motors in and around your workplace. Decide what type of motors they are. You'll need to create a list. Then look at whether they're single phase, three phase, induction, etc. And compare their physical size with their power rating. Look at the means of control that's been employed to control those motors in your environment. Okay, question, can I reverse the direction of any motor? Okay, alright, I've given you the answers here, okay? But determine what kind of motors you can reverse and what you cannot reverse, okay? And here we have a knowledge check, okay? Okay. Now make sure you can understand this and you write out the questions. Put pen to paper, write it out. Okay? Do not just take it for granted. Okay, I hope you found this useful. Have a good day. Terence Payne tutorial session. Please utilize at your leisure, and thank you for your time. Have a good day. I'm just going to work my way up now. Let me just drop this down so I can make sure I get everything in place for everyone to see. Okay, let me just make sure I make it back normal. Okay, I'm just recapping now. Okay. Okay. Just recapping, moving everything back into place so I can see what it is. Okay. Let me just drop him down. Okay, sorry. Okay, strange. Looks like I had to drop him down a bit well. 26. Next. Okay. Drop him down a bit more then. Let me just make sure I've got it in view, all in view. Okay. Bear with me for a second. Okay, let's go in that then. Thank you. Okay, thank you. Have a good day. I'm going to add a little bit extra to this now to give an idea. Hopefully it works. You can see here we have some auto transformers, starter control wiring systems and so forth in modern day. Okay, I'm not going to picture on this any further, of course. You can look this up for yourselves. Okay, a lot of it is available here. Okay, I mean, some of the stuff is just tremendous, and some of you would be working on a lot of this stuff already yourselves, so don't be afraid to extend your knowledge. If there's courses running, whether at college or at university, go and get those courses done, because you've got to upgrade your skill again and again because of the changing shape of technology all the time. Okay, that is important that you understand that. Don't just sit back and think the knowledge you have will suffice. By being willing to change and learn, you make a difference, give yourself a wider opportunity, and you may well end up being able to manage and direct rather than have to be hands-on. And it is always nice to be hands-free. Okay? See, all of did it come across there? No, this didn't give me what I want. Okay, so I'm going to close that. Had it? Possibly not. But let me just go back to here. Okay, and here we have a one guy doing something. Let me see what he's doing. Come on. You're just doing something. YouTube playing it. Okay. Auto transformer starter. Okay. Again. Okay. Okay. I hope you found this useful. Have a good day. Bye bye.